Welcome to the workshop. Today we want to take a look at section 3.7, conditional distributions. And we've already taken a look at conditional probabilities, so all that we want to do now is begin to look at what that looks like as a distribution. So we basically know what's going on here, just a little bit of an adjustment, maybe stepping back, looking at a bigger picture to get the distribution instead of a specific probability. So let's take a look at our lecture notes. So we're returning back to the same example that we considered in section 2.8 and that we again considered in sections, I think, 3.4, 3.5, and 3.6. So here we are visiting that same example again. We have the clerks who are filling orders, and they're making mistakes or they're not making mistakes. Okay, cool. So given that a mistake is not made, we want to find the probabilities that Larry, Mo, and Curly fill the order. So we can find those individual probabilities exactly the same way that we have been. There's nothing different about that. So we have, actually, let's make sure that we have our events quite clear. So let's make sure that we have that. So let's let L be the event that Larry, sorry, yes, no, that's right, Larry fills an order. There we go. And let's let M be the event that Mo fills an order. Looks like there's a typo there, and let's let C be the event. And I missed the T up here for event. There we go. The event that Curly fills an order. And then finally, let's let R be the event that no mistake was made. So in this case, the order was filled right. They did it right. That's all that we're trying to say there, to try and make sense of the use of the letter R for the event. So then all that we want to do is say, okay, we've got the probability that, as it specifies, given that a mistake is not made, what are the probabilities that Larry, Mo, and Curly fill the order? So the probability that Larry fills the order, given that no mistake is made, is exactly the individual probability that we had previously computed. So this is the probability, let's see, probability that both of the events occur, L and R, divided by the probability that the order is filled right. And then we want to find the probability that Mo filled the order, given that the order was filled right. And we have here that it's the probability of Mo filling the order and the order being filled right, divided by the probability that the order was filled right. And then finally, the probability that Curly filled the order, given that the order was filled right, is given by the probability that both of those things occurred, divided by the probability that the order was filled right. So this is nothing new, right? And if it wasn't clear, in the last section, we discussed how this row gives the probability distribution of, let's see here, I think I labeled these X and these, actually, X and these Y, 0, 1, 2, 0, 1. So we could see it as a discrete random variable. And this is the probability distribution of X, and this is the probability distribution of Y. Okay, so we have our distributions, the probability of R. So in this case, we're really looking at X equals no mistake, x equals 1. Okay, so this is what we're looking at in the context of discrete random variables. So we'd be looking at, let's see here, y equals, you get rid of all of this a moment. We'd be looking at the probability that y is equal to 0 given that x is equal to 1. Okay, so that's what we're looking at in terms of random variables. X equals, let's see here, well, y equals 0, comma, x equals 1. So that's writing it in terms of discrete random variables. So this is no different than what we've been taking a look at in the discussion on probability a while ago, and we're looking at it through the lens of random variables in this case, and we have the marginal distribution and the marginal distribution, which give us these probabilities, and then the joint distribution gives us the numerators. Okay, so 0 and 1. Let's see here, 0 and 1. So, yep, there, 0 and 1. Larry fills the order and no mistake is made. 0.2475 divided by probability that no mistake is made, 0.9685. And we do this for all of them, right? So we've got, again, I could rewrite this in the random variable notation. I'm not going to worry about that. I think you get the idea. So we're looking at mo given no mistake, 329 divided by 9685. And then probability of Curly given no mistake is 392 divided by 9685. Of course, I can compute each of these. So if we go ahead and do that, we find it's 0.2555, 0.3397, and 0.4047. So we get these three probabilities, but those are the probability, that's all possible values for no mistake being made, right? Low, Larry, Mo, or Curly. So this is the probability distribution for no mistake being made. That is, it's the conditional distribution of y given that x is equal to 1. Okay. So this is exactly the idea of a conditional distribution. So instead of the specific probabilities, we're just looking at the collection of them. And that's it. So we want to continue taking a look at this in this section, of course, give some nice definitions and then some examples. So I'll see you guys back in the workshop very shortly for some more definitions and examples on conditional distributions.